Hello, we are Team 3, and we are working on the automated ground delivery robot. Our design objective is to improve upon an already existing autonomous delivery robot for the SUNY New Paltz campus. The existing prototype has very limited capabilities in this respect, but many improvements will be made. Our goal is to make a robot that can securely deliver small packages to app users on campus with little to no human interaction. This project is important because in today's day and age, automation is the pinnacle of technology. Creating this robot can make tasks on campus a bit easier and reduce the face-to-face contact between students and faculty, which has become increasingly important throughout the COVID-19 pandemic.
So let's look into how this project is addressing this problem. Success in this endeavor can increase companies' operational efficiency, reduce labor costs and hazards, and avoid unnecessary interpersonal contact in a post-COVID-19 world. Robots can also maneuver through more treacherous environments than humans without compromising safety. The current constraints are a lack of funding to develop sensors for going down and upstairs. Batteries are another issue. Lead batteries are much cheaper than lithium-ion batteries, but weigh significantly more.
Don't want to go out? Well, the autonomous delivery robot can navigate the SUNY New Paltz campus. This is to help with deliveries to students, so they do not have the hassle of picking up packages in the mailroom or food from the campus restaurants. 2 iterations of this robot are planned. One will be the bare bones robot, which will be done this winter 2021, and the second and final iteration, which is planned to be complete by the end of spring 2022.
2 main engineering principles were used to get the robot moving. Using the power formula, the batteries were selected to provide enough power to the motors to give the robot enough torque and force for a velocity great enough to move. Using the torque formula, the torque from the motors for each wheel must be enough to overcome the force of friction opposing it, which is variant of the robot's weight. The prototype taught us problem-solving skills. There were several instances we had to be resourceful to come up with a solution to unforeseen obstacles. Teamwork and communication became increasingly important in putting the prototype together, as no one sub-team could do all aspects of the project.
For the incoming spring 2022 semester, we plan on adding sensors which will help the robot be more autonomous. Right now, the robot is limited to detecting obstacles it approaches from the front. By adding additional infrared sensors, plus the implementation of hypersonic sensors, this will give the robot a more complete picture of its environment and allow it to adjust its path accordingly. Additionally, GPS tracking for the robot will be implemented. Alongside the GPS tracking, we want to make an app that will allow any SUNY New Paltz student or faculty member to be able to see the location of the robot. This will allow them to track their order or just find where the robot is.
Next semester, we also plan to improve the locking mechanism in the frame of the robot to make packages more secure. We also plan to make the robot's movement more efficient. This semester, we had trouble with turning left and right, and our original plan did not work with the prototype wheels, so this problem will be addressed at the start of next semester. Our prototype was designed to be extremely bare bones, one sensor and just enough frame for the robot to function. When testing our prototype, we came up with a few problems that need to be addressed at the start of next semester. Going up hills is extremely difficult with the current prototype. Using GPS and rotary encoding, this problem can be fixed. The speed of the motor will be tracked using GPS, and when it slows down, we will have code to tell the motors to speed up. When the GPS is implemented, we will add capabilities for the robot to get directions to wherever the order needs to be delivered.